In this video tutorial, you will learn how to connect the key drill system, program the directional unit receiver, set the gravity tool face angle, perform a roll test, perform a tool test, set up widths, and navigate through the receiver window. Connecting the key drill. This is where the programming cable is connected, as well as the main cable to the right. Do not connect a serial cable to the gamma slot. This will affect how width tags are utilized. Gamma will be sent to the Envision computer from the MWD laptop. On the left side of the box will be the power connection and the USB connection to the laptop. On the receiver, the other end of the main cable is connected and the transducer connects to the right of it. The main cable and transducer cable are connected inside. The first thing you want to do is create a job folder on the desktop. Name it Job followed by the number from the well plan. Then open up that job folder and create 4 subfolders. The first folder will be Logs LAS. Then MWD data, reports, and runs. Open the runs folder and create a subfolder Run1. This is where you will store the config file. Now you're ready to start programming the tool. Open the key drill folder located on the desktop. Double-click KDT Tool Config. Select the default config file and click Open. Then you want to save as in the Run1 folder. Navigate to your desktop. In this case, I'm looking for job 1234. Navigate to Runs, open up Runs1, and name the file Run1 config followed by the date. When you click Save, a message will appear telling you that the file doesn't exist. Do you want to create? Click Yes. You're now ready to start programming the tool and receiver. Let's look at the main menu items. You can save, save as, view or change the location to store the config file, tools, access COM settings, QTalk, tool test, coefficient utility, which is only utilized by the lab, load configurations from the tool or receiver, store configurations to the tool and receiver, comparison. This will show you any differences between what is in the tool versus the receiver. Tool face offset will set the gravity tool face angle. Advanced options. You can enable or disable advanced variables, and also choose to display the time and pulses required to transmit surveys and tool face sequences. This is very useful when trying to estimate transmit and survey delay times. Save raw data should be checked. The remaining options will be discussed in a separate tutorial. Some of them do not apply to Phoenix operations. Instead of clicking the main menu items, you can click on the icons below. Open a config file, save, connect to the tool, run the TFO utility, which is the same as the tool face offset in the main menu, load and store configurations to the tool, save to the receiver, QTalk, compare tool and receiver config, test utility, directional sensor data. This is the same as the coefficient data utility. At the bottom of the window, you can click the tabs to jump to different programming variables: telemetry, mode, survey sequences, tool face logging sequences, site environment and battery, directional and gamma, pulse, and pump and flow. Let's start with the telemetry window. The only parameters that really need to be adjusted are transmit-receive delay times. Most other settings in this window are Phoenix defaults. Nonetheless, they must be checked even if they are grayed out. If you want to change a value, simply highlight the area or use the drop-down menu. Verify all other parameters. Survey header size set to 3, toolface header size 3, header check always set to parity, sync window factor set to 0, sync type set to 1111, number of sync pulses 3. Downlink control must be set to disable. This grays out all the other options in downlink controls. Inclination threshold set to 5 degrees and inclination evaluation set to survey. Click the Mode tab. Set the current mode number to 1, then assign the pulse width timing for each mode. The timing must be discussed in advance with your coordinator. Factors such as mud conditions and the use of agitators must be considered before changing this setting. 1 second is the default setting for all Phoenix jobs. Modes 1 through 4 must be the same. Click the SSQ1 tab. Here we have an example of a default config. Delete this and let's start from scratch, just to show you how easy it is to program a sequence. You will receive a message that the sequence must have one or more parameters. That's okay, just click OK. It might even appear a few times until you have something there. Select Survey Sequence 1 and start with an inclination at 12-bit with a parity check. Click Add and it will appear in Survey Sequence 1. The second parameter I want to add is azimuth at 12-bit with a parity check, followed by dip angle at 10-bit with a parity check. Then add the remaining qualifiers, gravity and mag. Add a temperature at 8-bit and a check to see if BAT2 is on. You will notice that the resolution will disappear when this is selected. BAT2 is either on or off. You still have the option to add, delete, or edit these parameters manually. For example, you can highlight the item and click delete, or cut it and paste it elsewhere in the string. The advantage of selecting the items first is that you can avoid syntax errors from typing in the wrong parameter. Once the sequence is complete, you must add it to each mode. Simply click Copy Number 1 to All and click Yes. You will see that all sequence modes are now the same. TSQ1. Programming the toolface logging sequence works just the same as the survey sequence with a few additional options. Let's do the same thing that we did when we programmed the survey sequence and start from scratch. You will receive the same message that it must have one or more parameters. Click OK. From left to right, you have repeat, items, resolution, and type of check. Let's select a toolface at 6-bit with a parity check and then click Add. This will appear in the line just below, which allows you to create subgroups or set the repeat of this group before adding to the sequence. Now, add gamma at 8-bit parity. Select the amount of times you want this group to repeat. I'm going to select 20. When you click the smaller Add button, brackets are applied to the toolface gamma set and repeated 20 times. Next, let's add a single tool face and a GV4, which is vibration on the Z-axis. You can see here I repeated the items but shouldn't have. Just highlight the items and delete. Make sure the repeat is set to 1 and start over again. So now I have a set of 20 tool faces in gamma, followed by a single tool face and vibe. We can repeat the 20 tool face gamma set by highlighting, then copy paste, or select from the menu items. Let's set the repeat to 10 times instead of 20. In this example, we are designing this tool face logging sequence so that there are no interruptions in the tool face update. I want to end the string with a tool face, temperature, and a GV5, which is vibration on the XY axis. I don't want to repeat, so I'll set this to 1. Now we have completed the sequence. 20 tool faces in gamma, single tool face in GV4, which is vibration on the Z-axis, then another set of 10 tool faces gamma, and end with a single tool face, GV5, which is vibration on the XY axis, and temperature. One of the things I wanted to point out is the attribute and type settings associated with generic variables. When you select any GV, make sure U, or unsigned, is selected under type, and attribute is set to 0. The attribute setting will affect the scale at which the generic variable is decoded, so it must always be set to 0. Like survey sequences, all 4 modes must be the same. Copy number 1 to all modes. I would like to reiterate, tool face logging sequences are configured to meet job site variables and must always be confirmed with your coordinator. This string is strictly for example purposes only. Next, click on the Site Environment and Battery tab. Populate the fields accordingly with information obtained from the well plan. Dip angle, nominal mag field, and magnetic declination are values that you'll receive from the well plan. Nominal gravity magnitude is always 1 and does not come from the well plan. The tolerance values are defined by Phoenix. Input 0.6 for dip angle tolerance. This will only work for XXT directional units, otherwise input 0.92. 0.01 is the lowest setting for magnetic field tolerance and 0.005 for gravity magnitude tolerance. Delta mag XY field tolerance should be set to 0.05. Low voltage threshold must be set to 23 volts and set the averaging time to 10 seconds. Next, click the Directional and Gamma tab. Note that most items in this tab are grayed out. Verify the following settings: high temperature threshold 125 degrees Celsius, true magnetic tool face set to off, survey delay time set to 30 seconds, survey sampling rate 128, and survey sampling time 4 seconds. Sensor power control enable. Survey acquisition mode no flow, sensor sampling rate 256, steering sampling rate 256, and steering sampling time 8 seconds. Sensor power control enable, sensor warm-up time 1 second, minimum sampling time 1 second, auto data acquisition off, auto output format on, surface gamma scaling factor 1, tool gamma scale factor 1, minimum sampling time 3000 seconds, auto acquisition update time 10 seconds, auto output format string gamma question mark semicolon GATT question mark. To change the survey delay time, click Advanced Options and enable Advanced Options. Any item can be modified, but the only item that should ever be modified is survey delay time with coordinator approval. After the change is made, disable the advanced features. Next, click Pulse and Pump Settings. A good starting point for low pulse amplitude is 30 psi and high pulse amplitude of 300 psi. Pumps on threshold set to 500 psi. Pumps on off evaluation time set to 5 seconds. Max pressure transducer set to 10,000 psi. Pressure transducer gain set to 1, and pressure transducer offset at 0. Flow detection method must be set to switch. Make sure invert flow is set to off, and flow on-off evaluation time must be set to 5 seconds. Now we need to store this configuration to the tool and receiver. In the main menu, click Store to the tool and receiver. This message lets you know that the config file is stored in the KeyDrill receiver folder, in addition to the file you saved in your job folder. Click OK to continue programming. The tool may not be high-sided at this point. We don't want to be prompted to perform this procedure. The config file has successfully been stored to the tool and receiver. Click OK. Click No for the TFO procedure. Now that we have stored the config file, we want to compare the values between the tool and the receiver to make sure they match. Click Comparison. If a value doesn't match, it will show up in red. The left column has receiver values and the right has the tool values. Once the comparison is complete, you can scroll down to see all values. Before you click Print, make sure to uncheck Run Test Utility. You want to save this file as a PDF inside the Run1 folder. Once you're finished, click Close. Physically high-side the tool, then click Tool Face Offset. This is where you will zero the gravity tool face angle. This shows the latest gravity tool face angle. We want to keep the mode to auto to automatically record everything we do in this window. You can uncheck the Run Comparison window. We've already completed this step. Now you can zero the gravity tool face angle. Click Yes and wait for the update. In this example, 290.3 plus 59.1 equals 349.4. There is the updated gravity tool face angle at 0 and the new TFO of 349.4. Now we can start the roll test. Rotate the tool to 90, 180, 270, and all the way back to 0. The TFO will not change as you perform this roll test. Now we're at 180. You always want to see at least 2 updates before moving on to the next test increment. We have rolled the tool from 0 to 360. Click Save and place it in the Job folder. Name it Run 1 Roll Test with the date. Click OK to the message. You can see that this file shows the TFO was zeroed. It also gives you the accelerometer and magnetometer values. Go to File and Print as a PDF and save to your Job folder. Close the window and exit Roll Test. Next, we want to perform a tool test. Click the Tool Test icon. This is where you can invert the flow and turn battery 2 on or off. The tool time can be set here as well. The accelerometer and magnetometer readings are displayed as well as values the tool is currently reading. Be sure to print this and make a PDF before closing. In the key drill folder, click on KDT Receiver. For job file format, select Run Number Based and check New Job. Leave the current file path as is and click OK. Select the correct serial port for input from key drill and output port to Envision. The output data must be checked as standard widths. Click OK and the message will appear that the configuration is loaded. Click OK again. Confirm the run number and verify the driller assembly offset is 0. Never click OK unless the DAO is set to 0. If there is a number other than 0, click Clear and then click OK. The receiver window will display all the necessary information needed while drilling the well. Let's get familiar with the display. You can quickly reference key items such as magnetic declination, drill assembly offset, and inclination threshold. It's a good idea to check this immediately after opening the receiver display to confirm the settings. To the left is the receiver controls data display, waveform, widths output, pumps on timer, reload view config, and gamma ROP plot. The rosebud displays toolface updates, decoding confidence, and the current ink and as. To the right, you have time, dip angle, pumps on and off time, pump pressure, and pulse amplitude. Just below is where the pulse wave will appear along with pressure if it's checked. Current received data is displayed to the right. In the Receiver Controls tab, you can adjust surface controls, warning flags, tool display format, decimal section, and sound selections. Data display will show recent data and events like pumps on or off. You can also select history, survey, or selected. The waveform window will display the pulses back to 80 seconds. WITS output settings are where you can verify WITS output IDs, serial ports, and output data format. Pumps on timer will display pumps on time either by run or daily. This is useful for reporting purposes. If for any reason you need to reload the configuration file, you can do this here. For example, switching to a backup key drill while you're drilling. Navigate to the folder containing the config file. After it's loaded, you can view the pulse width and mode settings as well as receiver and decoder settings.